All right, everyone, welcome back for another deep dive.
Yeah, glad to be here.
Today we're tackling software architecture.
Ooh, a big one.
It can get pretty complex, but luckily we have a guide, Just Enough Software Architecture by George Fairbanks.
A classic.
This book is great for anyone building software, no matter how experienced.
And what really stands out to me is how practical it is. Fairbanks argues we don't always need to over-engineer things.
You mean like, don't build a skyscraper when all you need is a garden shed?
Exactly. Fairbanks actually uses that analogy to explain that architecture is a separate concern from functionality. He's saying, don't get lost in the weeds before you even figure out what you're building.
Okay, that makes sense. But then, why is architecture so important, especially when we're always under pressure to deliver features quickly?
Well, Fairbanks argues that architecture is about managing risk. Think of it like a doctor diagnosing a patient before prescribing treatment. You need to understand the problem before you can solve it.
So you're saying it's about anticipating problems early on and making design decisions that prevent those problems?
Yeah, and Fairbanks has a name for this approach, risk-driven architecture.
Okay, I'm definitely intrigued. Can you give us an example of what this actually looks like?
Sure. Imagine you're building a home media player system. This system needs to handle various file formats, integrate with third-party extensions, all while being responsive, reliable, and easy for new developers to understand.
Oh, that last part's crucial. I've definitely struggled to understand other people's code before.
Right, it's like being dropped in a foreign country without a map.
Absolutely. So how does this team tackle that challenge in the book?
Well, they identify knowledge gaps as a major risk. They start by simply documenting the core components and their responsibilities. Like this component handles audio decoding, or that component manages the user interface.
So it's like outlining the major landmarks on that map.
Exactly. And then they take it a step further by creating a visual model of how these components interact. It's almost like a flowchart or a network diagram.
So this shows new developers how the different parts of the software work together.
Exactly. It gives them a clear visual representation of the system's dynamics. And they also model the interactions between components and any third-party systems.
That's pretty smart. It seems like a good example of that. Just enough principle, you're providing the information that's needed without over-engineering the documentation.
Yeah, exactly. It's about finding that balance. And then as the team continues to develop the home media player, they hit another challenge, integrating a complex third-party video component.
Oh, I could see how that would be tricky. It's like trying to fit a brand new engine into an existing car.
Exactly. You could run into all sorts of compatibility issues.
Yeah, you don't want your car to stall out every time you try to accelerate.
Right. So to avoid this kind of architectural mismatch, the team carefully analyzes the new components' interfaces and assumptions. They're essentially trying to predict potential conflicts before they even happen.
So they're proactively designing adapters or workarounds to ensure a smooth integration?
Exactly. It's about thinking ahead and designing for flexibility. And then Fairbanks dives into some other key architectural concepts that help us understand and manage complex systems. One of these is the idea of different models for visualizing and reasoning about software.
Okay, I'm interested. What kind of models are we talking about?
Fairbanks describes 3 fundamental models that work together to paint a complete picture of a software system, kind of like looking at it through different lenses.
Oh, yeah, I like that. So we got multiple lenses. What does each one show us?
So the first is the domain model. This one expresses the enduring truths about the problem you're trying to solve. It's about understanding the what before you dive into the how.
So like if we were building a financial application, our domain model would capture concepts like accounts, transactions, interest rates, that kind of thing.
Right, it's like becoming an expert in that specific field. Then you have the design model. This captures your design decisions and how the system will be structured. It shows us the how of the solution.
So that's where we start to draw up the blueprints for the software.
Exactly. And then we have the code model, the actual implementation in code. The functions, the classes, the modules, all of that. It's the tangible result of all the design work.
This analogy is really helpful. It helps me see software design as a structured, layered process.
And Fairbanks stresses that these models need to be consistent. You don't want a mismatch between the blueprint and the actual building.
Makes sense. I've definitely worked on projects where the code seemed completely detached from the design documents.
Ah, yes, code drift. Happens all the time, unfortunately. But by striving to keep our models aligned, we can minimize those gaps between what we intend to build and what we actually build.
That makes a lot of sense. And it makes me think about how we can better manage complexity in software. Is that something Fairbanks addresses?
Absolutely. He talks about encapsulation and partitioning as 2 key strategies.
Okay, encapsulation, partitioning. I've heard those terms before, but sometimes I get them mixed up.
Sure. Think of encapsulation like drawing a boundary around part of your system and hiding its internal complexity from the outside world.
So, like, I don't need to know how a car engine works to actually drive the car.
Exactly. And that's how encapsulation makes software more manageable. You can work on one engine without worrying about how it might affect other parts.
Okay, that's a good way to think about it. So then what about partitioning?
Partitioning is about strategically dividing a large system into smaller, more manageable parts.
It's like organizing a messy room by putting things into labeled boxes. Suddenly, it's much easier to find what you need.
Yeah, great analogy. And Fairbanks emphasizes that both encapsulation and partitioning are essential for tackling complex systems. He even has this cautionary tale about an accounting system where poor encapsulation led to a lot of confusion and unnecessary complexity.
Oh, a cautionary tale. I'm all ears. Tell me more.
Well, the system exposed way too many internal details. It's like trying to fix a leaky faucet and then finding yourself drowning in plumbing diagrams.
Oof, yeah, that sounds like a nightmare.
Right. The point is that effective encapsulation is about hiding unnecessary details and presenting a clear interface to the outside world.
So it's about making it easier for others to interact with your code without getting lost in the complexity.
Exactly. And this is a perfect segue into those pre-built solutions I mentioned earlier, the architectural styles.
Ah, yes, those architectural styles. I'm really eager to learn more about those. They sound like they could be really useful.
They had, and that's where we'll pick up in part 2. We'll explore some of those proven blueprints that Fairbanks highlights in the book.
Perfect. Can't wait to dive into those. See you on part 2.
See you there.
All right, welcome back, everyone. So last time we were talking about some of the foundational ideas from just enough software architecture, things like risk-driven design and those different models.
Right, setting the stage.
Now I'm really excited to get into those pre-built solutions. You mentioned those architectural styles.
Yeah, the architectural styles. These are like proven blueprints for tackling common design challenges in software.
So instead of reinventing the wheel every time, we can draw on these established patterns.
Exactly. Each style is kind of tailored to specific types of problems and quality attributes.
Okay, so it's like having a toolbox full of different tools. You wouldn't do a hammer to tighten a screw, right?
Exactly. So choosing the right style really depends on understanding the problem you're trying to solve and the risks you need to manage. There's no one size fits all.
Makes sense. So where do we even begin? Which style should we look at first?
Well, let's start with a classic, the layered style. It's all about organizing your software into distinct layers, each with a specific responsibility.
Okay, so kind of like a layer cake, where each layer builds upon the one below it.
Yeah, that's a good analogy. The key thing is that each layer can only communicate with the layer directly below it.
So that keeps things organized. It's like a well-managed company. Each department handles its own tasks and passes information up and down the chain.
Exactly. That clear separation of concerns makes the system much easier to understand and maintain. And it also promotes modularities and reusability.
Modularity and reusability. Those are good things, right?
Absolutely. It means you can modify or even swap out layers without affecting the whole system as long as the interfaces stay compatible.
That makes a lot of sense. Do you have a real-world example of this?
Think about how operating systems are structured. You have the kernel at the very bottom, then you have drivers, and then on top of that, you have applications.
Wow, I never thought of an operating system as a layered architecture, but now that you mention it, it's so obvious.
Right, it's everywhere. But okay, the layer style isn't the only one out there. Let's talk about another one that's super common and versatile, the client-server style.
Oh yeah, client-server, that one rings a bell.
Think of it like a restaurant. The diners are the clients, they place their orders, and the kitchen, that's the server, fulfills those requests.
Ah, I see. So this pattern is basically everywhere in the digital world too, right?
Yeah, think about web browsers. There are clients that request pages from web servers, or mobile apps that interact with backend servers.
So it's all about a clear division between those who request services and those who provide them.
Exactly. Now, how about we switch gears to something a little different? The pipe and filter style. This one's all about processing data in a step-by-step fashion.
Pipe and filter. Okay, I'm picturing data flowing through a series of pipes, and each pipe filters or transforms the data in some way.
Exactly. A good example is how compilers work. Source code goes through various stages like electrical analysis, parsing, code generation. Each stage acts as a filter that transforms the data.
So it's like an assembly line where each station performs a specific operation on the product as it moves down the line.
A perfect analogy. Now, one more I want to mention is the publish-subscribe style. This is all about broadcasting information to whoever's interested without needing to know exactly who they are.
So it's kind of like a radio station sending out signals anyone with a receiver can tune in.
You got it. This is really useful in event-driven systems where you have multiple components that need to react to events or changes in data.
Okay, so one component can publish an event, and any other component that's subscribed to that event will get notified.
Right. It's like a news agency sending out alerts to its subscribers. You don't need to know who they are, just that they're interested in that type of news.
I see. So beyond these four, are there any other important styles Fairbanks talks about?
Yeah, Fairbanks goes into some more specialized ones like the Model View Controller or MVC, which is super popular for interactive applications.
Oh yeah, MVC, that's one I've heard a lot about, but honestly still find a little confusing.
It's a common one to get tripped up on. It's all about separating the concerns of an application into three interconnected parts: the model, the view, and the controller.
Okay, three parts. So how do they all work together?
Well, imagine it like this. The model represents the data and the logic that manipulates it. Think of it like the brain of the application. The view is responsible for presenting that data to the user. That's like the face of the application. And then the controller sits in the middle.
So the controller is like the mediator. It makes sure the model and the view are talking to each other correctly.
Exactly. It handles user interactions and makes sure everything stays in sync. This separation makes MVC great for building applications with complex user interfaces. It allows for a lot of flexibility and modularity.
It's like having a team of specialists, one handling the data, one designing the look and feel, and one coordinating it all.
That's a great way to think about it. And just like any other architectural style, whether or not you use MVC really depends on the specific needs of your project.
This overview of architectural styles has been super helpful. It's like having a mental map of different ways to structure software.
And the important thing to remember is that these styles aren't just abstract concepts. They have a direct impact on how well your system performs, how secure it is, how easy it is to modify all these quality attributes.
Right, because ultimately we don't just want to build software that works. We want to build software that works well and can adapt to change.
Exactly. And speaking of adapting to change, that's a perfect segue into part 3, where we'll explore how to build systems that can stand the test of time and gracefully evolve with new requirements and technologies.
Awesome. I can't wait to learn more about that. See you all in part 3. All right, welcome back, everyone. It's great to be diving back into Just Enough Software Architecture with you all.
Yeah, always a pleasure.
We've covered a lot so far, why architecture matters, the different architectural styles, but now I'm curious about how to make sure our systems can stand the test of time. How do we build software that can evolve and adapt as things change?
That's a great question. And Fairbanks dedicates a whole section of the book to that very topic, how to manage change and evolution in software systems.
It's funny, when I first started programming, I thought the goal was to build this perfect, unchanging program.
Yeah, it's like building a perfectly balanced house of cards.
Right. But the reality is software is always evolving. New requirements pop up, new technologies emerge. It's like a constantly moving target.
Exactly. And Fairbanks makes that point really clear. Software systems are rarely static. They're almost like living organisms. They grow and adapt over time.
So then how do we actually design for that kind of flexibility? How do we make sure our systems can embrace change without breaking?
Well, Fairbanks suggests we start by designing for flexibility from the very beginning. Like, ask yourself, what parts of the system are most likely to change in the future?
So we need to sort of predict the future a bit.
In a way, yeah. It's about thinking ahead and anticipating what might need to be modified down the line.
And making design decisions that make those future changes easier.
Exactly. So that might mean choosing certain architectural styles, ones that support modularity and extensibility. Or it might mean designing clear interfaces between components so they can evolve independently.
So you can change one part of the system without having to rewrite the whole thing.
That's the idea. It's about minimizing dependencies and making the system as adaptable as possible. Fairbanks also talks about this idea of architecturally evident coding style.
Architecturally evident, what's that?
It means writing your code in a way that makes the underlying architecture visible and understandable. You're not just writing code for the computer, you're also communicating your design decisions to other developers.
Oh, that's a good point. It's like leaving a trail of breadcrumbs so anyone can follow the logic of your code.
Exactly. So you want to use meaningful names for classes and methods, structure your code to reflect the architectural components, even add comments to explain key decisions.
It makes me think of that quote from the book, "Code should tell a story about the system's architecture."
Ah, I love that one. It's about making your code more than just instructions. It's about making it a narrative that explains how the system works.
Yeah, it makes the code more human readable, which is so important when you're working on a team. And it also makes me think back to a discussion about encapsulation and partitioning. Those concepts seem really important for managing change, right?
Absolutely. When you encapsulate complexity and partition the system into well-defined modules, you're creating a more flexible and adaptable structure. It's easier to change one part without affecting the whole.
So all of these ideas kind of work together. It's like a holistic approach to building systems that can evolve gracefully.
Right. But let's be real, managing change can still be pretty tough. It's not always straightforward.
Yeah, there are always trade-offs to consider, right?
Definitely. Like sometimes adding flexibility might mean sacrificing a little performance. It's all about finding the right balance for your project.
It's about understanding the priorities and making informed decisions about where to focus your efforts. And sometimes being just enough also means accepting that you can't predict everything.
Exactly. You'll never be able to anticipate every possible change or new requirement.
So it's about building a system that's robust enough to handle the unexpected.
Right. And Fairbanks emphasizes that software architecture is really a journey, not a destination.
Oh, I like that. It's an ongoing process of learning, adapting, and refining your design as you go.
Exactly. And Fairbanks ends the book with this really thought-provoking question. What if every software project clearly identified its top architectural risks up front?
That is a good question. What if we all took a more proactive approach to managing risk?
It's about shifting our mindset from reactive problem solving to proactive risk mitigation. And that's really the heart of just enough software architecture. It's about designing with intention, anticipating change, and building systems that can evolve gracefully over time.
Well, I have to say this deep dive has been a real eye-opener for me. I feel like I have a much better understanding of software architecture and its role in being great software.
I'm so glad to hear that. I hope all our listeners feel the same. Just Enough Software Architecture is a fantastic resource for anyone involved in building software, and I invite everyone to check it out.
Yeah, I second that. It's been a pleasure exploring this book with you.
Likewise. And to our listeners, keep learning, keep exploring, and keep building awesome software.
Until next time, 620M Tunes.